I thank each one of you for watching my videos all these days. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the question paper CSIR National Eligibility Test held in the month of June 2023. This question is from real analysis and it is related to the uniform continuity of given functions. This question is from part C, which is a multiple select question. There can be more than one answer. This question carries 4.75 marks. The question ID is 704065. This question is suitable for all these examinations also. Right. The given question is define f, a function from r power 4 to r by f of the four tuple x, y, z, w is equal to xw minus yz. Which of the following statements are true? We are given four options. Option 1, f is continuous. Option 2, if U is the set of all four tuples x, y, z, w belongs to r to the power of 4 such that x, y plus z, w is equal to 0, x square plus z square is equal to 1, y square plus w square is equal to 1, then f is uniformly continuous on U. Option 3, if V is the set of all four tuples x, y, z, w belongs to r to the power of 4 such that x is equal to y, z is equal to w, then f is uniformly continuous on V. Option 4, if w is the set of all four tuples x, y, z, w belongs to r to the power of 4 such that 0 less than or equal to x plus y plus z plus w less than or equal to 1, then f is unbounded on w. Right. Let's now discuss the solution of the problem in detail. We have a function f from r power 4 to r defined by f of x, y, z, w is equal to xw minus yz. Call on the first option, f is continuous. F defined like this, is it continuous? Yes, it is continuous. Why? Because f of x, y, z, w is xw minus yz. xw minus yz is a polynomial in four variables x, y, z, w. And every polynomial is continuous. Therefore, f is continuous. F is continuous because xw minus yz is a polynomial in four variables and every polynomial is a continuous function, therefore f is continuous. Thus option 1 is true. Move on to the next option, option 3. We call on if V is the set of all four tuples x, y, z, w belongs to r to the power of 4 such that x is equal to y, z is equal to w, then f is uniformly continuous on V. Right. So now take the quadruple, the four tuple x, y, z, w belongs to V. And the condition, this implies the condition is x is equal to y, z is equal to w. And what will be f of x, y, z, w? It will be xw minus yz. X into w is z, xz minus y is x, xz. xz minus xz is 0. For all x, y, z w belongs to V. That means f is a constant function. F is a constant function. That means it is sending every a 4 tuple x, y, z, w belongs to V to 0. So thus, for all x, y, z, w belongs to x, y, z, w belongs to V, f of x, y, z, w is 0. That means on V, f is a 0 function. That means it is a constant function. So that is f is a constant function on V. And every constant function is continuous and uniformly continuous on its domain. So f is uniformly continuous on V. Since every constant function is continuous and uniformly continuous on its domain is V, on V. Thus, option 3 is true. Move to the next option. We take up option 4. If W is the set of all 4 tuples x, y, z, w belongs to r to the power of 4, such that 0 less than or equal to x plus y plus z plus w is less than or equal to 1, then is f unbounded on w? That's the question. Right. Consider x is equal to 1 minus n. Means we want to consider such a 4 tuple as x is equal to 1 minus n, where n is a natural number, y is equal to n, z is equal to minus n, w is equal to n. W is equal to n. So now the sum of all of them, x plus y plus z plus w is 1. Is 1. Thus, x, y, z, w belongs to w, capital W, and substitute what will be the f of x, y, z, w for these 4 tuple. So f of x, y, z, w is equal to x, w minus y, z. X is 1 minus n, w is n, minus y is n, and z is minus n. Right. Simplify. If simplify, you will get n. Now, as n tends to infinity, f of x, y, z, w is equal to n tends to infinity as n tends to infinity. That means f is unbounded on w. Thus, f is unbounded on w. Thus, the option 4 is also true. So far 3 options we have seen. All those 3 options are true. And the remaining option is 4. Option 2, sorry. Next option. We go to the next option, option 2. And we have the function defined like this. And so far we have seen options 1, 3, 4 are true. We have already seen f is continuous. For this function, f is continuous. Now, option 2, if u is the set of all 4 tuples x, y, z, w belongs to r to the power of 4, such that x, y plus z, w is equal to 0, comma, x square plus z square is equal to 1, comma, y square plus w square is equal to 1, then required to prove f is uniformly continuous on u. Agreed. So for this, for uniform continuity, we wish to show that u is a compact set in R power 4. In R power 4, who are compact sets? Those which are closed and bounded. So we want to claim u is compact. That means we want to show that u is closed and u is bounded. First, u is bounded. How do you show u is bounded? So let's see. For all 4 tuples x, y, z, w belongs to u, we calculate its norm. Norm of x, y, z, w will be under the square root of x square plus y square plus z square plus w square. Is the Euclidean norm. And x square plus z square is 1. Y square plus w square is equal to 1. So it is under the square root of 1 plus 1, that is root 2. That means all the elements of this will lie in an open ball, in a ball, in a ball with center 0 and a radius, some number bigger than root 2. So this shows that U is contained in the ball with center 0 and radius 2. Because root 2 is 1.4, 2 is bigger than that. So thus U is a bounded subset of R to the power of 4. So our next concern is U is closed. We want to show. Yes, U is closed. Note that U is the set of all 4 tuples x, y, z, w belongs to R to the power of 4 such that x, y plus z, w is equal to 0, intersection all 4 tuples satisfying x square plus z square is equal to 1, intersection those 4 tuples which satisfy y square plus w square is equal to 1. So U is written as the intersection of these 3 sets. Agreed. Now let alpha, beta, gamma be functions from R to the power of 4 to R defined by alpha of x, y, z, w is the first one, x, y plus z, w. Beta of x, y, z, w is x square plus z square. And gamma of x, y, z, w is equal to y square plus w square. So then U will be, and note that alpha, beta, gamma are the continuous functions because these are all polynomials and every polynomial is continuous. Agreed. So U is written as the set of all those 4 tuples x, y, z, w belongs to R to the power of 4 such that alpha of x, y, z, w is equal to 0 because x, y plus z, w is equal to 0 and alpha is x, y plus z, w. Intersection with the second one is the set of all 4 tuples x, y, z, w belongs to R to the power of 4 such that beta of x, y, z, w is equal to 1. Beta of x, y, z, w means x square plus z square is equal to 1. The intersection of all those quadruples x, y, z, w such that gamma of x, y, z is equal to 1. Right. Now we write U as alpha inverse of the single 0. Alpha inverse of 0 will be all these quadruples you will get. Intersection with beta inverse of 1. Intersection gamma inverse of 1. We write it as singleton sets. Right. So what are these singleton sets? Singleton 0 is in R. There are singleton sets in R. Because it is R power 4 to R power 4. R power 4 to R power 4 to R. So these are singleton sets. These are finite sets. Every finite set is closed. So these are closed sets. And what is alpha? Alpha is continuous. And alpha inverse of a closed set. Alpha inverse of a closed set. Alpha is continuous. Alpha inverse of a closed set is closed. Beta inverse of closed set is closed. Gamma inverse of this closed. So what is this? The intersection of closed sets. How many? 3. Finite intersection of closed sets is closed. Therefore, U is closed. Beautiful argument. So note that alpha inverse of singleton 0, beta inverse of singleton 1, gamma inverse of singleton 1 are closed subsets of R to the power of 4 since alpha, beta, gamma are continuous and these are singleton sets are closed subsets of R. And a map phi from R power 4 to R is continuous if and only if F inverse of C is closed in R power 4 for every closed set C in R. You are using that one. So thus U is closed in R power 4 because it is the intersection of 3 closed sets. So this is closed in R power 4 since the finite intersection of closed sets is closed. So U is closed. Thus U is closed here, and previously we have shown U is bounded. Therefore U is closed and bounded. Therefore U is compact. And what is F? F is continuous function. So F on compact sets. So a continuous function on compact set is uniformly continuous. Therefore F is uniformly continuous on U. We argue this in the next slide. Right. We have shown U is bounded, U is closed in R power 4. Thus U is compact by Heine-Borel theorem. What the Heine-Borel theorem says? A subset S of an Euclidean space R power n is compact if and only if S is closed and bounded. Right. And now F is continuous and U is compact. So continuous function defined on a compact space is uniformly continuous. So this implies F is uniformly continuous on U. Thus option 2 is also true. Option 2 is also true. Thus all the options 1, 2, 3 and 4, they are all true. So the answer to this question is options 1, 2, 3 and 4. That is the detailed discussion of the solution of this problem from the section real analysis, which is related to the uniform continuity of given functions on given sets. And because all of them are true, workout will take longer time in the examination hall. So that is a minus point. Otherwise, it is a relatively an easy question, but in the examination hall, it may be a difficult one. I am sure that you understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We hope to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.